In today's video, we are going to learn how to calculate F equals ma, which is also known as Newton's second law. As we go through these problems, I have 5 of them for today. I think you will find them very helpful when working your problems online. Also, a lot of these are going to be very repetitive. So make sure that, again, you're using your video capabilities to pause, try to do the calculations on your own, fast forward, rewind, and again, if you're watching on YouTube, you can watch it in 1.5 or 2 times speed if you feel like you're comfortable with it, but still want to see me work out the problems. For our first problem, we have an object with a mass of 3.5 kilograms that accelerates at 8.7 meters per second squared when a force is applied to it. What is the amount of that force? So just a quick review, I have our F equals ma formula located right at the top. For force, our units of force are newtons, and that's a capital M, or excuse me, a capital N. For mass, we measure mass in kilograms, and for this formula, the mass has to be in kilograms. So if you receive it in grams, you're going to need to convert that. And lastly, we have A for acceleration, which is measured in meters per second squared. We line up all of our variables out to the side. It's asking us to solve for force. That gets the question mark. We have a mass of 3.5 kilograms with an acceleration of 8.7 meters per second squared. All of these are in the correct units. We have kilograms and meters per second squared, so we can therefore just plug in everything straight to the equation. Again, make sure you're writing down these units because you'll be able to catch yourself if you need to unit convert because they won't be able to combine in the correct manner. If we put this in our calculator, 3.5 times 8.7, we get 30.45, and then our unit is going to be kilogram times meter divided by second squared. That's going to be the same thing as 30.45 newtons, because remember, 1 newton equals a kilogram times meter per second squared. So this will be our final answer. On our second problem, an object accelerates at 3.0 meters per second squared when a force of 5 newtons is applied to it. What is the mass of the object? So in this one, it is asking us to solve for the mass. It's given us a force of 5 newtons and it accelerates at 3.0 meters per second squared. Newton and meters per second squared, those are the correct units. So we just need to plug it into the formula. Now for this, it's asking us to solve for mass. So we need to rearrange until we get mass on a side by itself. So we need to get A on the other side. So currently it's being multiplied. To undo it, we divide. And so our formula will work out to be mass equals force divided by acceleration. Now we can plug in our numbers. So 5 newtons divided by 3.0 meters per second squared. This is going to give a value of 1.6, and it's repeatable 6, so I'm just going to round it to 1.67. Now, in terms of units, you may be wondering, well, how does a newton cancel out with a meter per second squared? The easiest way to think about this, okay, remember 1 newton equals 1 kilogram times meters per second squared. So here, in this units right here, what it actually means is we have a newton, so 5 kilogram times meters divided by second squared, all divided by meters per second squared. Here we have meters per second squared, cancels out meters per second squared, and we're left with kilograms. So there's going to be kilograms. Also remember that mass has to be in kilograms. So as long as your units are correct to begin with, then you can just simply put kilograms as your units. An object accelerates at 8.3 meters per second squared when a force of 1700 newtons is applied to it. What is the mass of the object? This is going to be just like the one we just did. Okay, so force, mass, acceleration. Our force is 1700 newtons. Our acceleration is 8.30 meters per second squared, and we are solving for a mass. Again, here's a great time to pause the video. Try to work this out on your own. We have our formula. If we rearrange our formula, and you can go back to the previous slide to watch that, we get mass equals force divided by acceleration. So it's going to be 1700 newtons divided by 8.30 meters per second squared. If we put that in our calculator, it gives us a value of 204.8 kilograms. So that is going to be the mass of this object. Here, an object with a mass of 4 kilograms accelerates at 2.5 meters per second when a force is applied to it. What is the amount of the force? So this is going to be like the first problem we did, where we solve for force. So question mark goes to force. Mass is 4 kilograms. Acceleration is 2.5 meters per second squared. Everything's in the correct units, therefore we can just plug it into our variables. So 4 kilograms, remembering to write our units of course, times 2.5 meters per second squared. This is going to give us a value of 10, and when we combine our units, it's kilogram times meter divided by second square, which is the exact same thing as a newton, and newton are our units of force, so that makes sense. For our last problem, an object accelerates at 12.7 meters per second squared when a force of 3.90 newtons is applied to it. What is the mass of the object? Force, mass, acceleration. Again, we want to know the mass. It accelerates at 12.7 meters per second squared with 3.90 newtons of force added to it. If we rearrange our formula and solve for mass, mass equals force divided by acceleration. That's 3.90 newtons divided by 12.7 meters per second squared. That gives us a value of 0.307. And what are our units for mass? Kilograms. So that would be our final answer. Again, if you have any questions as you're going through solving these problems, please send me an email, let me know, and I will be more than happy to help you.